In June 2022, a team of Australian scientists discovered an extremely bright quasar, which was shining through telescopes with its blinding fountain of light. Till now, many massive black holes have been observed in this infinite universe. But a black hole as massive and powerful as this has probably never been seen before. This hungry monster is one of the most active and dangerous black holes in the observable universe. You can get an idea of its hunger from the fact that it swallows as much material as the mass of our Earth every second. Since its birth, it has consumed so much matter that its event horizon, or you could say that its boundaries have shifted quite far away. Its mouth is so wide that our entire solar system could fit inside it. Its mouth is so wide that its width is so great. It's huge. Every star in this universe that is born, it's not necessary that it has a beautiful and complete family of planets and satellites like our sun. Some are unfortunate, lonely, and aimless wanderers who keep drifting here and there in open space. In such a case, if there is a star that is about 20 times bigger than our sun and it undergoes a massive explosion, it takes the form of a black hole. However, this is not like a typical black hole. In this universe, everything is relative. That means every celestial body is in motion. In such cases, some black holes are especially stationary with no internal movement of any kind. But due to extremely massive cosmic explosions and some rare events, they show displacement. Now look at this universe. Nothing is in an absolute state of rest. Every object is in some kind of motion. Whereas the reality is far from this. In fact, all these planets follow this spiral pattern. Now, since our sun is orbiting the supermassive black hole present at the center of our Milky Way galaxy, that's why, in our own galaxy, the Milky Way, there are nearly 100 million such black holes. These are lost wandering travelers, and at any time, they can collide with any star. According to an estimate, about 5,000 light years away from Earth, no such star has been observed with such a black hole. In the past, it has been studied several times by the Hubble Space Telescope. As a result, we have obtained a lot of important information related to it. For example, we have even succeeded in measuring its exact weight. When that happens, it causes a massive explosion, and that's how such dangerous black holes are born. They have a wandering nature. They roam through space looking for their prey. Everything that comes in their path gets swallowed by them. Anyway, a distance of 5,000 light years is quite a lot. So for now, we don't need to be afraid of it at all. But that doesn't mean we can just sit back and relax. Because what we're about to show you now, it has its own companion star. In terms of weight, it's 10 times heavier than our sun. Meanwhile, the most surprising thing is that its companion star still has planets and satellites like any ordinary constellation. This black hole can exist at a distance of only 80 light years. That means it would be extremely close to us, with only a few constellations separating it from us. Pause for a moment and consider what might happen. If a black hole is hiding right in our own solar system, all of you would have the same answer to this. Right now, we would be destroyed by coming into the grip of that black hole. This is not entirely true. Black holes are not of just one type. There are many classes among them as well. As a result, the planet's atmosphere will be completely destroyed and all life present here will also be instantly wiped out. The coming consequences will be worth seeing. One by one, all the planets will start to break apart and scatter. They have death, but only if the black hole is a small primordial one, not a destructive monster. In the past, after the tremendous explosion of the Big Bang, matter spread throughout the entire universe in various amounts. Meanwhile, in places where the amount of matter was less, some special regions were formed there, where due to the intense force of gravity, some small black holes were created. They gradually started pulling in and accumulating the matter present around them, and this is how these primordial black holes began to form. You will be surprised to know that these black holes have existed since the early days of the universe, and they are among the oldest things present in this universe. Their size can range from that of a large star to as small as your eye. Many researchers believe that our entire universe is filled with these tiny primordial black holes. It is said that there could be thousands of small black holes even within our own solar system. It's quite difficult to say how much truth there is in these claims, but the science behind it is truly fascinating. So, as far as the destruction of our Earth by these black holes is concerned, we don't need to worry too much about this for now, because all astronomical surveys so far indicate we are safe. So far, no such black hole has been traced near the Earth that could swallow our entire solar system. And anyway, the black holes present in the infinite universe are far beyond our imagination, and their basic principle says that instead of wandering here and there in the universe, they stay in one place and pull everything around them into themselves, and in this way, their existence continues. But are you interested to know what will happen on the day of judgment when a dangerous black hole comes very close to our Earth and pulls us inside it? What will happen within a year from the time the black hole reaches us to the moment it swallows us? At different times in this world, there have been many people who have tried to predict the end of time and Earth. They gave an exact date when the apocalypse would come, when everything would be swallowed by time. These prophets or enlightened individuals are not associated with any single religion or culture but have emerged in different eras and environments all over the world. Whether it's the great European philosopher Nostradamus or someone from the ancient land of Macedonia, Baba Vanga, who gives messages about the future. We humans have always been eager to know and predict our future. Whether it's the date of December 21, 2012 or the warning of doomsday on April 23, 2018, these so-called prognosticators announce some date like this every year. The day when human civilization or the entire planet Earth is supposed to be destroyed in some catastrophe. But these dates come and go and nothing happens. In such cases, these things just seem like empty, smooth-talking words that have no real basis. People associated with astrology have their own beliefs about this. Whether it's a giant asteroid entering deep into the Earth or something intending to swallow the entire solar system, scientists think we're nearing our end, whether it's due to a black hole or something else. Soon, two massive black holes are about to collide in space. As a result, this thriving planet will turn into a graveyard. Let's find out the inside story of this whole matter. But today, I have accepted this truth. There are celestial objects whose number in this universe could range from millions to billions. Recently, scientists observed some strange activities happening in a galaxy. These activities indicate a terrifying collision happening between two black holes there. This galaxy, named Saris J1430 plus 2303, exists. It is about 1.1 billion light years away from us. The time it takes for a Legion event is quite short. Therefore, in a real-life scenario, it would take a considerable amount of time for this event to occur. Scientists have suggested that these black holes will take about 3 years to completely collide and merge into each other. If we set aside the terror of destruction for a moment and look at this as a research opportunity, it would be a landmark point in the entire history of astrophysics, where we humans will witness an event that is not only super rare but also something that very few people ever get to see. But there is a problem here, and that is, even now, scientists are not 100% sure about this. In galaxy SRSJ 143002 1303, what we're imagining will actually happen. There is definitely a little confusion about this, but our understanding so far tells us that we are moving in the right direction. A few years ago, in 2015, scientists observed some small black holes in space that were extremely close to colliding with each other. During the observation of these black holes, a truly astonishing pattern of cosmic catastrophe emerged before us. As a result, scientists learned a lot about the behavioral changes of these massive bodies present in the space fabric and the action of gravitational waves. A dedicated gravitational waves observatory has also been set up to study the gravitational disturbances and waves generated by black holes, where the most modern and advanced gravitational wave detection instrument to date is present. Of course, for an ordinary person, witnessing these catastrophic events happening in space would be a terrifying experience. But for the researchers working on such observations, it's just a part of their job. Witnessing any massive black hole collision or impact explosion is an absolute treat for these detectors, because after that they get all the information related to that event, which proves to be very helpful in enriching their scientific database. If for a moment all our observational instruments fail to detect those waves generated by these collisions, in that situation, many facts are excluded from visual study. As I said earlier, light has an amazing significance in space, especially from a research perspective. Light is very important because whenever such massive events occur, a big explosion is created, which releases a huge burst of light. And when we capture this light and read its data and try to understand it, we find out exactly what's happening there. Through the photometrical investigation of the entire event, we learned fascinating things about the collision, impact, and the physics of both objects. For example, when these phenomena were investigated in depth, it was found that the event of black holes merging doesn't just bring destruction, it also creates a marvelous cosmic object. After two black holes merge, a single, much larger and more destructive black hole forms. I am sure you must be familiar with the fun of galactic mergers, and even if you aren't, let me quickly tell you that in this universe, one galaxy also interacts with another galaxy. And when they come face to face in their paths, they merge together. Galactic collision is one of the most dramatic events in this universe. In fact, this is the very event that provokes two massive, supermassive black holes to collide with each other. Well, you all already know that usually there is only one supermassive black hole at the center of a galaxy. Most of the elements of the galaxy revolve around it. In such a situation, when a merger happens between galaxies, eventually the black holes of both galaxies also encounter each other. In such a case, the weaker black hole surrenders to the stronger one and becomes a part of it forever. Astronomers have named this event a binary merger. To detect this, scientists study the fluctuations of light in a particular galactic cluster, which suddenly makes the picture of black holes coming closer in declining orbits much clearer. The galactic nucleus, that is, the center point of a galaxy, is probably one of the strangest things in this universe. It's quite difficult to understand the signals coming from here. Also, the center of each distinct galaxy tells a completely different story, and to understand it, we have to choose a new approach every time. Scientists in China conducted research on the massive SRS J1430+2303 galaxy. They used X-ray wavelengths as the basis for this research. They hoped this would help them understand the high energy waves from the black hole, and to a great extent, they were successful in their plan. They tried to understand this gigantic black hole. Wave observation data from around 200 days was collected from different observatories around the world. When the data was analyzed collectively, they found that there was a change in the light coming from the center of this galaxy, and this was only possible if two giant monsters were merging here. This fluctuation in light was only on a major scale, which completely rules out the presence of any other factor, and this proved that we have indeed witnessed the biggest black hole collision so far. As far as space catastrophe is concerned, black holes can certainly become a reason for the destruction of our beloved solar system. In reality, they are so powerful that they have the strength to swallow everything completely. In that case, a small system like the solar system is nothing in front of a black hole. So, that's a separate issue. This is about the year 1970. Physicist Stephen Hawking was searching for the answer to a very simple question. Do black holes have a temperature? Believe it or not, this single question changed some of the fundamental ideas about our universe. The belief was that this universe is infinite and eternal. There will be no end to it, but the search for this question took Stephen Hawking into a completely different world. From there, we got more information about how a hole works. And the conclusion that came out was that black holes also radiate energy, which means that even black holes, which absorb everything, will gradually lose energy. And a time will come when all the black holes in this universe will eventually evaporate and nothing will be left in this universe. Now, you might have a lot of questions in your mind about this conclusion, like if the energy that black holes are radiating should remain, but wait, how can black holes even radiate energy? Because what we all know about black holes is that their gravitational field is so strong that not even light can escape from them. So how can any radiation come out? By the way, that radiation is called thermal radiation or Hawking radiation. Besides this, you may have seen high energy jets from black holes. In many places, we also call them relativistic jets. That first famous picture of the M87 supermassive black hole, where these energetic jets are clearly visible to us. So how are all these things coming out of black holes after all? Anyway, a black hole is a mysterious and weird place. So, is our science falling apart there? Otherwise, how can anything come out of a black hole? So first, we need to understand what a black hole is. After this, all your doubts will be cleared. So let's first talk about black holes, because the root of all confusion is hidden here. So simply, if we try to visualize what a black hole actually is, so first of all, let's assume that if space is empty, if there's nothing in space, then the fabric of space will be completely flat. If we place a massive object in space, then a curvature will appear in space. The greater the mass of the object, the greater the curvature in space will be. That means there is a direct connection between mass and curvature, and its vice versa is also true. If there is more curvature in space, it means there is a massive body there. If the curvature is less, the object's mass is less, and if there is no curvature at all, then the object is also massless. Now we have understood the concept of space, its curvature and mass. You can understand this in real life like a crater or a big pit. Suppose you are standing at the edge of a pit, and by chance, if your foot slips, you will roll towards the center of that pit. This pull in space-time is called gravity. The greater the curvature, the stronger the intensity of gravity will be. Now suppose that after rolling, you reach the very center of the pit, which means you are at the center. That means you have landed on a massive body. But now, if you want to get out of that pit, that is to get out of a massive body, to escape its massive gravity, we need to apply a specific amount of energy, and that energy is what we call escape energy, escape velocity, velocity or escape speed. With this understanding, you can better imagine a black hole. Now suppose you put so much mass in one place in space that the curvature it creates in space, the pit it forms, is so deep that even the fastest object in the universe, that is light, cannot escape from it. That means even light doesn't have enough energy to get out of that curvature. Now we all know that the speed of light is the ultimate cosmic speed limit. That means any particle that has mass cannot achieve this speed, and the particles that are massless can only go up to the speed of light. This means that nothing can escape from the curvature created in space. So understand that a black hole has formed there, whose escape velocity is much greater than the speed of light, but even a black hole has its own limits. Let's understand this with our pit analogy as well. As long as you are far from that pit, you are completely safe. But as soon as you enter a critical region where you slip and keep falling into that pit, that's the event horizon. If you fall in, there's no escape. No matter what you do, you will keep falling inside the black hole and eventually stop at the singularity. Singularity is a point where all the mass of the black hole is concentrated. If you want to know more about this, you can watch our video. You will find the link in the I button above and in the description box below. Objects outside the event horizon can both escape the gravity of the black hole and also fall into the black hole. That depends on their properties. Now from here, we know that any object that crosses the event horizon can never come back. So then, how does matter and radiation get released from a black hole? So for this, imagine yourself as a particle that is just outside the event horizon of a black hole. Obviously, since you are near the black hole, its gravity will place you in an elliptical orbit. The closer you get to the black hole, the more your speed will increase. You won't fall into the black hole until you cross the event horizon. Now, there are many particles orbiting the black hole just like you, and you will be interacting with them. The disk formed in the orbit of the black hole is called the accretion disk. The scene of the accretion disk is such that particles are colliding with each other there. Because of friction, the entire disk heats up, and due to this heat, radiation is emitted from that accretion disk. This radiation is called thermal radiation, so actually the radiation is not coming from inside the black hole. Instead, it is being emitted from the matter outside the event horizon. So one confusion gets cleared up here. However, some of the matter in the accretion disk still loses energy and goes inside the event horizon. Because of this, that matter reaches the singularity and the mass of the black hole increases. Apart from this, a lot is happening around the black hole as well. In the accretion disk, many charged particles are traveling at the speed of light, and because of their dynamics, a magnetic field is created around the black hole. This then accelerates the ionized particles in a special helix shape, and this acceleration happens at the speed of light. And this is what we call relativistic jets. They are very bright and can be seen from very far away in space. There is a galaxy called Centaurus A from whose central black hole these jets are coming out in both directions, while in M87 it has been seen coming out in a single direction. But the important thing to understand here is that these jets and all the energy stored in them do not come out of the black hole. Rather, it is because of the ionized particles orbiting in the accretion disk around it. Even there, nothing is coming out of the black hole, nor can it. The gravity of the black hole accelerates the particles present in the accretion disk outside the event horizon, where the particles get heated up due to friction and collision. They become ionized, which generates electric current and magnetic field in them, and then this magnetic field accelerates these particles in one direction. This is the simple concept behind relativistic jets. Now let's talk about the most complicated, Hawking radiation. It's a bit complicated, but we'll try to understand it in a simple way. So first of all, as we discussed in the beginning, if we remove everything from the fabric of space, even the black hole, that space will become a flat vacuum surface. Now we all know that the fabric of space gets curved, so if we place a black hole at one point, the space there will obviously become curved. An event horizon will form and nearby space will follow the universe's fundamental laws. Now the result of this will be that radiation will start emitting from a large region around the black hole, which will be black body radiation, and it will come out in all directions. This radiation is what we call Hawking radiation. So now where is this radiation coming from? Because we have assumed that there is nothing in space except the black hole. So obviously that radiation must be coming from inside the black hole itself. Because here there is nothing even outside the event horizon, all the energy released in that radiation must come from the mass of the black hole itself. But here our common sense tells us that nothing can come out of a black hole. So how can Hawking radiation come out? And how can it be proven? If we look at Einstein's famous equation E equals mass times the speed of light squared, then here we can say that with every quantum of energy in Hawking radiation, that is, with every packet of energy, E amount of energy is coming out. So the black hole will lose m amount of mass. But how will this happen? What will be the mechanism of this whole process? Let's find out. The very first and most common simple explanation was not given by Hawking. But this couldn't satisfy the scientists, although it gave us a new way to visualize energy. So this explanation goes something like this. When space is empty, the energy present in it is called zero-point energy, which has a non-zero positive value. Now, even though space is empty, meaning it's vacant, from the perspective of energy, we can't treat it as empty. We need something there that can occupy that energy or neutralize it, because the energy in space is obviously already positive. And when you combine this fact with the Heisenberg uncertainty principle, a concept emerges in front of you. What happens is that in that empty space, pairs of matter and antimatter keep coming into existence continuously. They exist for a very short time and then annihilate each other, making the space empty again. This process keeps happening everywhere in space on a massive scale. Now you can assume that the same process would be happening at the event horizon of a black hole. Suddenly, two particles emerge from empty space, one matter and the other antimatter. Think of it as one being a particle and the other an antiparticle. If one has positive energy, the other has negative energy. Now one member escapes the event horizon, the one with positive energy, and the other particle which carries negative energy. It falls into the black hole, which will decrease the mass of the black hole. So this explanation was suggested by Hawking, but this explanation was for virtual particles which we cannot physically observe. And in Hawking radiation, photons are released, so was it not correct to conceptualize it with matter and antimatter particles? And most importantly, as we mentioned earlier in the case of Hawking radiation, it is released not from the black hole's event horizon but from a larger area around it. But if you still want to go with this explanation, then you will have to think about 4 different conditions here. Because there is no guarantee that the positive particle will always escape the event horizon and the negative particle will always go inside the black hole. So here are these 4. Possible cases can be formed here in which neither of the particles will cross the black hole's event horizon and they will annihilate each other and get destroyed. Number 2, out in pairs. In this, the particle escapes the event horizon and the antiparticle goes inside the black hole. Number 3, in-out pairs. In this, the particle falls into the black hole and the antiparticle escapes the event horizon. And number 4, in pairs. In this, both particles go inside the event horizon. Out of these 4 scenarios, there are only 2 conditions where a photon can be released, and that is through the interaction of in-out and out-in pairs. The energy released from those particles as photons must originate somewhere. Now, it's not like a particle just came into existence from nothing and released energy, and that energy is direct. It can't come from inside the black hole, because our understanding says that nothing can come out from inside a black hole. But there was a concept we saw at the beginning of the video, and that was that curvature and mass are directly connected to each other, and it's the curvature that links the black hole to the outside physical world. So this very concept is going to help us in this problem here, so that missing energy will come from the curvature of space. Now, as soon as the curvature decreases, because some energy has already been lost from it. In the same way, the mass of the central black hole will decrease, and through this very slow process, the entire black hole will eventually disappear. So this was Hawking's explanation, but even here, the radiation did not come out from inside the black hole. Rather, it is released from the particle being formed outside the event horizon, and in exchange, the energy that was lost came from the curvature of space-time, and that reduced the mass of the black hole. However, not everyone liked this explanation, because no one knows how the space-time fabric works at the quantum level in regions of high curvature, and especially near a black hole. But quantum field theory does have some answers for this. Calculations of quantum field theory in curved space have given us some really surprising results. This is thermal and black body radiation from the black hole. It's being emitted from the event horizon, and it depends on the size of the event horizon. For example, the smaller the event horizon, the greater the curvature of space there, and the higher the curvature. The rate of Hawking radiation will also be higher, meaning the rate of Hawking radiation will not always remain the same. For example, if there is a very large black hole, as time passes, its mass will decrease due to Hawking radiation, and it will become smaller. A black hole with the mass of our Sun would take 10 to the power of 67 years to evaporate. The central black hole of the Milky Way would take 10 to the power of 87 years to evaporate. And the largest black hole in the universe would take 10 to the power of 103 years to evaporate. And by then, every star in this universe will have died. Particles will have moved infinitely far apart from each other, which means our entire universe will have died by then. This is our galaxy way. It's just a small part of our universe. Our galaxy is neither smaller nor larger than the other galaxies seen in this. Our universe is so unique that there are galaxies found here that are millions and billions of times bigger than the Milky Way. And at the center of all these is what drives these giant galaxies. A giant black hole, the master of darkness, which is one of the greatest mysteries of this endless universe. As far as we have come to know black holes, they have always been a center of attraction for all of us. The most mysterious and so immense that there's no need to even describe their power. These cosmic giants, who are often described as terrifying, remain hidden at the centers of galaxies. These unimaginably powerful giants have been present in the universe's history ever since the universe has existed. Scientists have recently found some evidence that suggests black holes existed in our early universe much earlier than we previously thought. This discovery could change our understanding of the early universe. After all, what were these mysterious objects doing at the very beginning of the universe? How did they form so quickly, and how did they evolve in that early universe? Astronomers have been puzzled for a long time about the presence of quasars in the early universe. The discovery of quasars in the early universe means that supermassive black holes existed there, and this conclusion surprised scientists even more. These observations have raised many questions. How could supermassive black holes form in the early universe, which was not even a billion years old yet? While they had just learned how to grow. A study has been published in the Astrophysical Journal Letters using data from the Hubble Space Telescope. And this study has revealed that the early black holes were less luminous and were growing in a universe filled with darkness. Because of this unique characteristic, they had managed to escape our notice until now. This astonishing discovery not only deepens this mystery even further, but it also provides us with a lot of new information about the formation of black holes. Let's go on a journey of black holes today and see how these black holes were forming in the early universe. What has the James Webb Space Telescope told us about black holes? Let's take a look at that as well. Today, let's go on a journey about black holes. In science, one of the biggest mysteries so far is how supermassive black holes came into existence right after the Big Bang. Quasars, which are among the brightest objects in this universe, are powered by giant black holes. Scientists observed these quasars in galaxies from the early universe, when the universe was not even a billion years old. Now, these objects are such that in a billion years, their growth to the extent that they become supermassive black holes and form quasars is just not possible. It's like if I ask you, have you ever seen a 10-year-old old man, you'd say, how can someone be born and become old in just 10 years? Same. Scientists are also puzzled by this case. If they had so little time, then how did they grow up so quickly? When it comes to black holes, they grow by swallowing the gas, dust, and other things around them. All this matter falls into the area of the black hole's accretion disk. And then from there, it slowly gets absorbed into the black holes. A limit is set which directly affects the growth of black holes. Considering this limit, scientists are unable to explain how, despite this limit, black holes became so massive in such a short time back then. The two possible solutions given by scientists are as follows. Either these giant black holes must have formed from some stellar mass black holes which are massive, they're remnants of a star. Those that die very quickly take less time to reach the stage of a supermassive black hole. But if this process speeds up a little, they can grow within a given limited time. Now, because they start off with a mass 1,000 times heavier than our sun, that's why they're also called heavy seeds, and because of this, they quickly reach a large size. But where did these heavy seeds actually come from? One theory suggests dark matter halos. This is a structure made of invisible matter which holds galaxies together. This structure is very massive. They even trap gas clouds in large amounts and prevent those clouds from turning into a star. When stars do not form from those gas clouds, then they collapse directly into a black hole, which leads to the formation of a large heavy seed. The problem still remains. Only a few dark matter halos have been found to be large enough to trigger the direct black hole collapse. Black holes formed in this way should be found in very small numbers in the early universe, because the dark matter halos that create them were themselves quite rare. But a recent new research shows that the number of black holes we have observed in the early universe is much higher than our calculations. And because of this, astronomers are now forced to believe that some very mysterious forces were at work in the early universe, because of which our current science is unable to understand them. Now, how can it be that there are black holes and there is no mystery associated with them? Because of black holes and these wonderful discoveries and advanced technology, astronomers are now able to find black holes hidden in galaxies present in the early universe. Earlier, we could only detect those bright quasars because they are very bright. But recently, observations from the Hubble Space Telescope have also discovered many less luminous black holes, which had remained hidden from our view until now. Scientists monitored 15 years of brightness data from galaxies, which has enabled them to estimate the black holes that are quietly growing in the universe. This method has given us new data, which shows that the number of black holes we previously assumed to exist, in reality, their number in the early universe is many times higher. James Webb Space Telescope has taken this discovery even further. Thanks to its extraordinary sensitivity and advanced spectroscopic capabilities, James Webb Space Telescope has also started hunting faint black holes in the early universe. It is closely monitoring their activities. This telescope is also capable of detecting the faint glow of black holes hidden within galaxies. This will help astronomers refine our early models of the cosmos. But then this raises another question. If there were so many black holes present at that time, how did they all grow so quickly? After all, where did so much matter come from for them to consume? According to scientists, the answer to this might be hidden. Black holes have varying eating habits over time, unlike stars, which don't grow continuously. Instead, they have a gap in their eating times. They take breaks, which makes it difficult to estimate the actual rate at which their size increases. Black holes deceive us here as well. This discovery is also groundbreaking because it contradicts our previous model, meaning it proves the model we created to be wrong. Scientists now believe that all the black holes discovered so far, from the extremely bright quasars to the recently discovered less bright black holes, there are so many of them that they couldn't all have formed from collapse. This suggests that there must have been some extremely mysterious processes at work at that time, which were creating not only large but also a huge number of these black holes. In the next 5 years, the James Webb Space Telescope is going to play an important role in solving this cosmic puzzle. Its ability to observe faint black holes also gives scientists the power to witness the death of the earliest stars. And this event can tell us where the initial seeds of black holes came from in such large quantities and how the universe continued its journey forward. Apart from the standard theories of black hole formation, scientists now have even more. They are considering strange and unusual ideas. So that the black holes of the early universe can somehow be explained, and these strange and unusual ideas. But when dark matter is present in that normal star formation, something mysterious happens. As soon as the gas present in the cloud contracts, that is, shrinks, it captures a large amount of dark matter particles, and these particles modify the internal structure of the normal star that is about to form in such a way that the process of nuclear fusion at its core stops, which is what makes stars shine. Without the fusion process, this star cannot shine like a normal star, but it lives much longer than those stars and becomes extremely massive. And eventually, these stars collapse under their own weight and turn into a black hole, which is much larger than any normal stellar mass black hole. It's interesting to think that if these objects existed in our early universe, they could explain the observation of so many black holes that we see. However, dark stars are still a theoretical concept for us today, an imaginary idea. But large telescopes like James Webb Space Telescope can play an important role in proving the existence of such stars. Observing the collapse of those early stars with their telescope, it can tell us whether dark stars played a major role in black hole formation in the early universe or not. This adds another exciting possibility to the growing list of questions about these black holes. Are there some processes at work in the universe that we haven't fully understood yet? Black holes research has great potential for fascinating discoveries. In just the past few years, there has been a new revolution in research in this field. Upcoming missions like the Euclid mission and the Nancy Grace Roman Space Telescope will help not only in observing faint black holes, but also in detecting faint quasars. Meanwhile, observatories like the Square Kilometre Array or Square Kilometre Array being built in Australia and South Africa will help us understand black holes in greater depth. Currently, James Webb Space Telescope leads this research. By observing some of the faintest black holes in the early universe, it is helping us refine our old models. In the coming years, with its help, we will also succeed in finding a star collapsing, and that discovery will be historic. We are trying to learn and understand our own history, but perhaps the universe is such that whenever we get close to understanding its origin, new questions arise before us along the way. Friends, what are your thoughts on this topic? Do let us know in the comments section. If you like this video, be sure to like it and share it with your friends. For more such informative videos, make sure to subscribe to the channel and turn on the bell notification.